Okay, so in this short video, we will be discussing about two theorems. The first theorem on probability is concerning the probability of a event which is complement of a given event E. Okay, so that is called as E complement. So the first theorem says, let E be an event. Okay, let E be an event with the sample space S. So the theorem says the probability of the event E bar, which is the complement of S minus, the complement which is S minus E, is given by the probability of E bar is nothing but 1 minus P of E. Okay, and that we can easily prove. The proof of this statement is, so we need to find what is P of E bar. P of E bar is nothing but P of S minus E. So E bar is S minus E. And now P of S minus E, according to the Laplacian definition of the probability, it is this S minus E, where S is the cardinality of S minus cardinality of E divided by cardinality of S. So that is a definition of the probability of the event S minus E. And now these are all numbers, so you can easily simplify into this 1 minus E divided by S, and 1 minus E divided by S is nothing but the P of E, right? So we get 1 minus P of E, and that is the first theorem. So if I want to find a probability of an event E, sometimes finding a probability of an event E will be difficult. So in that sense, you can find probability of E bar, and then you take 1 minus P of E bar, and that will be nothing but P of E, right? So P of E bar is 1 minus P of E, and likewise P of E is equal to 1 minus P of E bar, right? So likewise, we will take one example. So where finding P of E bar is easier than finding P of E. Okay, so for that first example, we will take this one. I'll take the screenshot of that and then put it in OneNote. So let us put this here and enlarge it. Okay, so this is the theorem, which says a sequence of 10 bits is randomly generated. Okay, what is the probability that at least one of those bit is 0? Okay, so you are selecting 10 bits randomly. What is the probability that at least one of those bit is 0? Okay, so at least one of those bit is 0. It's not difficult to get, but it will be lengthier process, right? So in that case, if I take the complement of that, at least one of the zeros complement is nothing but none of them has to be 0, right? So E bar is none of them has to be 0, and this is what is this, right? So finding P of E bar will be easier, and that way you can find what is P of E. Okay, so P of E is nothing but now 1 minus P of E bar, and P of E bar is you can find what is E bar divided by S. So 1 minus E bar divided by S. So if I want to get a sequence which is not having any zeros, then you need to get 1, 1, 1, 1 like that 10 times, right? And what is the choice of getting 1? Every time when you select 10 times, 10 bits, right? So it will be 2 into 2 into 2 into, so that will be 10 times actually. So that is why we get this formula, we get this equation. So 1 minus 1 by 2 to the power 10, and that is nothing but the probability of getting at least one of the bit is 0. And 1 divided by 2 to the power 10 is nothing but 1024. So 2 to the power 10 is 1024, and so you will get the value as 1023 by 1024, and that is the probability of getting at least one of the bit as 0. Okay, so that is the example which shows instead of calculating what is P of E, we will try to find through P of E bar. Okay, so that is the application of first theorem. Then we have the second theorem, which is also very easy. The second theorem states that if there are two events, let me enlarge it. If there are two events, E1 and E2, okay, so this is the two events we have, and then the theorem says probability of E1 union E2 is nothing but P of E1 plus P of E2 minus P of E1 intersection E2. Okay, so this you need to prove. This we will show using a set theory formula that we already know. Cardinality of E1 plus cardinality of E2 minus cardinality of E1 intersection E2. Okay, so now we will find what is P of E1 union E2, and that is nothing but, according to the Laplacian definition, it is this formula, right? And that can be elongated like this using this equation. Okay, so E1 cardinality of E1 plus cardinality of E2 minus cardinality of E1 intersection E2 divided by cardinality of S, and that can be easily simplified, and we will get cardinality of E1 divided by cardinality of S, and that is nothing but P of E1, cardinality of E2 divided by cardinality of S, and that is nothing but P of E2, and cardinality of E1 intersection E2 divided by cardinality of S, and that is nothing but P of E1 intersection E2. Okay, and that's what you need to show. Okay, so that is a theorem 2. Now we will see one application of this theorem, which is also quite easy. Okay, so let us take that example out, and I'll paste it here, then elongate it. So this is a problem which says, what is the probability that a positive integer selected at random from the set of positive integers not exceeding 100 is divisible by either 2 or 5? Okay, so you are selecting at random from a set of positive integers not exceeding 100. Okay, and you need to see whether they are divisible by 2 or 5. So that is our event. So E1 is one event which is divisible by 2, and E2 is another event divisible by 5. So E1 intersection E2 means it is divisible by both 2 and 5. So now we can, so what we are asked is either 2 or 5. So what we need to find is P of E1 union E2, and that is nothing but, according to the previous theorem 2, it is this formula, P of E1 P of E2 minus P of E1 intersection E2. And what is P of E1 is nothing but the numbers from 1 to 100 which are divisible by 2, and that is, there are 50 numbers of that, and divided by the sample space, that is 100. And how many numbers are divisible by 5? So there are only 20 numbers which are divisible by 5, right? So 5, 10, 15, 20, like that, right? So those numbers are divisible by 100, divisible by 5, and that is divisible by the sample space, that is 100, right? And minus those numbers which are divisible by both 2 and 5. So that is only 10 numbers are there, 10, 20, 30, 40, like that, until 100, right? So that is 10 divided by 100. So when you simplify that formula, you will get that when you simplify the equation, you will get the number as 3 divided by 5, and that is the probability of getting a number which is divisible by either 2 or 5. Okay, so that's how you need to use the theorem 2 to find the probability, which is something like an event 1 union E2, which is either E1 or E2 has to be successful when you are doing the experiment. Okay.